Down here, at ground level, the water is moving fast. A tiny bamboo raft bobs against the current, and our subject is weighing his options at the edge of a perilous crossing. Hamsters are naturally wired to cover miles of terrain every night, foraging and navigating complex obstacles. But when we place them in a standard cage with basic plastic tubes, those deep-seated survival instincts start to atrophy. To keep a captive animal's brain truly healthy, we have to introduce cognitive enrichment. That means building complex environments that force them to actively solve problems. Today's objective tests exactly that. Our subject needs to make a completely dry crossing from a simulated wild island back to the mainland habitat. The engineering tolerances for this are strict. The vessel has to remain perfectly buoyant through turbulent water, because a single snapped lashing or structural failure means a soaked, highly unhappy passenger. True enrichment means introducing a measure of controlled, simulated danger. We have to create a scenario that requires the animal to wake up those dormant instincts and actively save itself. The vessel starts with raw materials. We harvest young, narrow bamboo shoots and cut them down to a strictly rodent-appropriate scale. This diagram shows a cross-section of a single bamboo stalk. You can see how the hollow internal chambers trap air, providing a natural upward buoyant force that directly counteracts the downward weight of our passenger. To assemble the deck, we use primitive hand lashing techniques, weaving natural sisal fibers tightly around each stalk. As the diagram transitions, it shows how rope tension creates a rigid platform. Downward pressure on one stalk is instantly distributed across the hull, keeping the craft stable. Before boarding our live passenger, we run a weighted test in the water. We load the raft with lead weights equivalent to a heavy Syrian hamster to ensure it resists capsizing under maximum load. Meticulous engineering is the absolute prerequisite. The physics of the craft have to be foolproof before introducing a living, unpredictable biological variable to the equation. The river itself spans 6 feet of custom-built channels, dropping slightly in elevation to mimic a natural waterway. Beneath the surface, high-capacity aquarium pumps constantly cycle the water, generating a rushing surface current capable of sweeping the raft downstream. We purposely placed mossy river rocks along the channel. These break the water flow, creating hydrodynamic eddies, swirling reverse currents that will aggressively test the raft's rotational stability as it passes. To ensure safety, the finish line features wide, gently sloped exit ramps. Once the raft makes contact, the passenger has an immediate fail-safe path to dry land. Building a simulated, dangerous environment demands far tighter safety controls than a standard habitat. The goal is to challenge the subject intensely while guaranteeing zero actual harm. Our subject approaches the shoreline. Driven by natural curiosity, he carefully steps onto the unfamiliar, textured bamboo deck, sniffing the lashed seams to assess his footing. The mooring line drops, and the raft immediately spins into the fast-moving center current, taking on splashing water at the edges. Instinct takes over instantly. As the craft tilts, he rapidly drops his center of mass, splaying his legs to lower his gravity and counteract the severe pitch of the deck. He is physically and visually mapping the water flow in real time. When the raft hits the swirling water of a hydrodynamic eddy, he braces his hind legs, anticipating the sudden bumps and rotational shifts. The current carries the vessel through the final rapid, and the bamboo hull firmly strikes the exit ramp. He immediately bounds off the deck and onto the dry shore. Navigating that volatile crossing forced rapid, real-time problem-solving. He had to react, balance, and calculate, an intense engagement of his survival wiring that a static, plastic wheel can never replicate. On the mainland, he immediately receives a high-value sunflower seed reward, locking in a positive reinforcement loop for completing the complex task. His physiological state shows clear signs of healthy, intense stimulation. His heart rate is elevated, his ears are perked, and he is highly alert. This radar chart compares 4 metrics: cognitive load, motor skills, balance, and problem-solving. The raft heavily outperforms the wheel. Now, this overhead map tracks the exact path. Notice the speed drops highlighted in eddy zones. The bamboo held perfectly even when rotational forces peaked. Merging primitive survival engineering with daily pet care, visibly elevates an animal's mental acuity. It treats them as active explorers with natural capabilities rather than passive captives. We have the data from this crossing, and we are already scaling up the engineering for a much more complex canopy bridge challenge. Subscribe to see how our subject handles the next vertical expedition.